All right, so let's keep going. Example 4. So the heights of American males are normally distributed with a mean of 69.3 inches and a standard deviation of 2.8 inches. So again, starting out, label your graph. So we have 69.3 inches right smack in the middle, and then keep starting to add your standard deviation. So that's giving us 72.1, 74.9, 77.7, and then subtracting from the 69.3, 66.5, we have a 63.7 and a 60.9. Percentages, again, 34 and 34, 13.5. And again, I know this can sometimes take a while, but again, the more you write these in, the easier it's going to be to remember them, and it will hopefully become second nature on these kinds of problems. Alrighty, so first problem, what percentage? So we just need to add up sections. What percentage of males are shorter than 69.3 inches? Well, where's the 69.3 again? Right smack in the middle, so half of them are shorter, half of them are taller. Okay, how about taller than 72.1 inches? So again, we're just looking for percent here. Didn't ask how many. So taller than 72.1, we're adding together 13.5 plus 2.35. Sorry, that plus sign didn't work well. Plus 0.15%. Add those all up, and we are going to get 16%. So again, if you think of it towards the right of the curve, so not a whole lot of people are that tall. 72 inches, again, I believe 72 is 6 feet. So between 66.5 and 74.9, and add up your sections. So we're going to get 34 plus 34, percent. Let's see. And then we have to go, let's see, up to 74.9, we have to add in a 13.5. Add those all up together, we should get 81.5%. Actually, let's circle the final answers. And so you also have a notation in here, and this notation means exactly the same thing. So part D, which says P parentheses X less than 63.7, all this means is, what is the probability that a score X is going to be less than 63.7? It's the same thing we've been already doing. So we want to look at our 63.7, and we want to add together all the sections below that because we have less than on this section. So 0.15% plus 2.35%. So we're looking at 2.5% of males are shorter than 63.7 inches. Again, for reference, 60 inches is 5 feet. Alrighty. So part E, probability that a score is greater than 66.5. So again, we're looking at 66.5 and all the sections above it. So we can do this two ways, add up all the sections or subtract the ones we don't want away from 100. I'm going to go ahead and add up the sections. And actually, I'm thinking about this 69.3 is the halfway point, so I only have to add that extra 34%. So 34% plus the extra 50 to the right-hand side, that's going to give us 84%. Alrighty, back to candy. So the Skittles in a package is normally distributed with a mean of 18 and a standard deviation of 1. So again, start out by labeling your diagram. Mean 18 goes in the middle. Standard deviation of 1, this one's easy to multiply out. So we have a 19, 20, and a 21. Subtract to go the other direction. So your packages hover around 18 pieces of candy total. Okay, so what percentages of bags have more than 19? We need to know what percentages, so label those in. And again, you'll notice every time I'm labeling these, I always just tend to start with the middle. That's just the way I have them memorized. $2.35. And again, whether you can draw a perfect bell curve or not does not matter. It really just gives you that visual organization to know what pieces you need to add together. Okay, so more than 19 means we need to take the 13.5% plus 2.35 plus 0.15, add them up, and we should get 16%. Okay, less than 15 Skittles, only that one little section, 0.15%. Between 16 and 18, add them up, 13.5 plus 34, which gives us 47.5%. Okay, question D, they had to throw one of these in here. So if there are 150 packages of Skittles, how many will have more than 17 pieces of candy? So again, figure out our percentage first. So 17, what's going to be more than 17? Well, our probability is going to be, it's half the curve plus an extra 34%. So 34 plus 50, it's giving us 84%. And so 84% of 150 packages, 0.84 times 150, that's going to give us 126 packages. And then for E and F, we're right back at probability. So again, probability of being between 19 and 20. Well, those are just two spaces away from each other. What's the percentage that's in between them? That's just 13.5%. And then what about greater than 20? Again, just add the two smaller ones together. Alrighty. As always, let me know if you have any questions or concerns about this. If not, get started on your practice. Talk to you later.